Welcome to Chapter 10-1. This video is about the area of different quadrilaterals. Area is something that you guys should be really familiar with, so this should be a pretty easy section for you all. What we're going to look at is the area of parallelograms, triangles, kites, rhombus, and trapezoids. So let's get started with some easy ones. Here we have a rectangle. If you don't know how to find the area of a rectangle, then you should probably go back to 6th grade math. So the area of a rectangle, we all know, is the base times the height. So here we have the base, here we have the height. If we have the base is equal to 2, the height is equal to 3, 2 times 3, the area is equal to 6. Alright, so moving on to something a little bit more difficult, the parallelogram. So the parallelogram is a four-sided shape. The opposite sides are parallel. A lot of time when looking at areas, it's best to break up the shapes. So if I turn this into a right triangle, and imagine I break off this triangle from here, and I move it right here where there's an open space. So I break this triangle off on the left side, and I move it over to this open space on the right side. Our shape is going to make a rectangle. So the area for parallelograms is actually the exact same as the area of a rectangle. Area is equal to the base times the height. Where the base could be either on the top or the bottom here. We have the base or the base down here. And the height is going to be the altitude going straight up. The only time students usually get messed up on these kind of problems is when they put the height out here with the diagonal looking piece. We do not want that. The height is always going to be going straight up and down, perpendicular to the base. All right, moving on, we have triangles. So a triangle, I have 3 different kinds of triangles here. I have a right triangle, we have an acute triangle, and we have an obtuse triangle. The formula is the exact same for each one. So the right triangle, once again, I make another shape here. If we had a triangle, we just kind of flipped it on itself, it would make a square. Or a rectangle. So we know that the area of a square or a rectangle is the base times the height. And a triangle is just going to be half that. So here we have the whole base times the height, but the triangle is just going to be half that. So our base is here, our height. Once again, it is a line perpendicular to our base. So right triangles are the easiest to find the area of. It's basically just multiplying the 2 legs together with the base and the height and times a half. The acute triangles are a little bit more difficult. Here we have a base, and the height is not going to be here, and it's also not going to be right here. The height is the altitude. So the altitude is perpendicular with the base going up to the top of the triangle. So our formula is the exact same. Area is equal to 1/2 base times height, but our height we have to find. It's going to be this altitude going up here. You guys will see that we can use SOHCAHTOA, Pythagorean theorem, and some different ways to find that altitude. So an obtuse triangle is a little bit more difficult. We still have our base down here, this bottom piece here that's flat, but our height goes from right here to right here. So the height of this triangle is going to be from our base going straight up perpendicular to our base to the tip of the triangle, our height here. And our formula is the exact same. The area is equal to 1/2 base times the height. All right, kites. A kite, you guys know from flying them probably, looks something like this. All right. So I'm going to break my kite up into 4 sections. I'm going to put in, that's called a diagonal, and this is another diagonal. So notice now if we do that, we have 4 triangles. 2 large ones and 2 small ones. So with these 4 triangles, we know that the area of a triangle is equal to 1/2 base times height. So a kite's going to be similar. If I were to change this kite into a rectangle, the area of this rectangle would be double my kite, because this triangle here is the same as this triangle, and this triangle here is the same as this triangle. Same thing with my smaller ones. So I found the area of this rectangle with a base and a height. I could just divide it by 2. Now if we look at the diagonals of the kite, this long diagonal going up here, we can call that diagonal 1. And we can call my diagonal going across here, all the way across, diagonal 2. So if I multiply diagonal 1 times diagonal 2, that's going to give me my base times my height, which will be the area of this big rectangle. Now my kite is going to be 1/2 of that area. So the area of a kite is 1/2 of our diagonal 1 times our diagonal 2. The last shape that we have, or second to last shape we have, is a rhombus. A rhombus is similar to a kite. Rhombus are hard for me to draw. We'll see how I do here. So a rhombus is a diamond shape. Remember that it's not a very good rhombus. Sorry about that. Remember, rhombus, all the sides are congruent. It's kind of like a square, but it is squished flat. So a rhombus is going to be the exact same formula as my kite. Area is equal to 1/2 diagonal 1 times diagonal 2. Because we can do the same thing. We can make a rectangle around this rhombus. And the rhombus is going to be equal to half the rectangle. Diagonal 1 and diagonal 2, it doesn't really matter which one you use for diagonal 1 and diagonal 2. I could say this one's diagonal 1 and my long one's diagonal 2, or vice versa. I could say that my long one is diagonal 1 and the short one is diagonal 2. All right, moving on to our last shape, the trapezoid. Trapezoids have 2 parallel sides, and those are the bases. So we call them base 1 and base 2, and they have 2 legs on either side. The formula for a trapezoid is a little bit more complicated. A trapezoid is kind of similar to a rectangle, but it's not quite a rectangle. We have a height here of our trapezoid going up, but I have 2 different size bases. So what I'm going to do with this trapezoid is, you guys remember the mid segment in the middle here? That's the average of the 2 bases. If I take the average of the 2 bases, that's going to be the base that we use for my formula. So the area of a trapezoid is going to equal 1/2 of base 1 times base 2 times our height. So this 1/2 times the base 1 times the base 2, that's the average of these two bases, which it gives me, this is going to be 1/2 times base 1 times base 2. That's the average. So we're going to take the average of our bases and then multiply it by our height, and that'll give us the area of any trapezoid. Okay, the last topic for today is multiplying some different objects together. So hopefully we know how to do some of these. We have 2 times 4 here, which everyone's saying, okay, Mr. Wilmus, that's easy, it is 8. I just want to show you a different way of multiplying 2 times 4. So the idea of multiplication is that we have a unit that is 2 times a unit that is 4. So this object is 2 units long and 4 units long this way. So if we count all our pieces, 1, 2, 3, 4, 5, 6, 7, 8, it is equal to 8. 2 times 4 is equal to 8. So we can do the same thing when we're multiplying with some variables. So I'm going to make a square here. Let's say this side is 3 long and this side is x plus 2 long. All right. So 3 times x is 3x. 3 times 2 is 6. So if we add these two pieces together, we get 3x plus 6. So if I multiply 3 times x plus 2, I get 3x plus 6. Same idea here. We have a side that is x plus 2 long and x plus 5 long. So if we multiply all of our parts together, we get x squared, we get 5x, we get 2x, that is 2 times x here, and 2 times 5 is 10. So I just multiplied all our parts together. X times x is x squared. This x times this 5 is 5x, so this little section right here would be 5x. Here we have an x times a 2 for this square, and the last one 2 times 5. So we get x squared. The sum of all of our parts then will be these two multiplied together. So we get x squared plus 2x plus 5x plus 10. And we can simplify a little bit right here in the middle to give us x squared plus 7x plus 10. And that would equal to my x plus 2 times my x plus 5. X squared plus 7x plus 10. All right, the last one here, I'll let you guys do on your own. I'll go ahead and give you the answer. We should get x squared plus 1x minus 12. So see if you can do it on your own. Make our little square here and multiply them together and see if you end up with the same thing. If not, you can ask me about it in class. Hope you enjoyed the lesson. We'll see you in class.